Okay, my name is Goran Klepac. I came from Croatia, Hrvatski Telekom, which is the part of T-Com, and today I just would like to highlight some things in relation with artificial intelligence, usage of the artificial intelligence in telcos, and also some things which is potentially, from my point of view, a little bit misunderstanding regarding the fact that we have several trends on market. And from I would say, experience, this is, I would say, my highlight from this point of view. First of all, this is, I would say, some kind of introductory part. As you can see in here, we have to ask ourselves, do we really see what we should see from our data? Mostly, I suppose that you are witnessing in situation when everybody told, okay, you have to plug and play some kind of, I would say, magical solution on your data, then you will get predictive models, you will get recommendation model, whatever, but unfortunately that's not true. Maybe on first sight you will have the impression that you have something which is valuable, that has very great ROC curve or something like that, but at the end you will be faced in several months with disappointed situation. And the question is how to perform in this situation. I was in one situation maybe 2 or 3 weeks when one vendor just claimed it was, I would say, famous vendor for one reporting system. And they say, we finally just introduced artificial intelligence in our solution. Finally, you don't have to know anything about artificial intelligence and programming and modeling. You just have to plug and play your data and you will get predictive model. Then I realized that I really don't believe to this solution, because to all of you which has any experience in good modeling, you are pretty sure that that's not the case. You have to invest your time for data preparation, data sample preparation, to know your data, to shape your data, to have strategy how to reshape, how to avoid the situation that you will have some kind of overfitting and so on and so on. And generally speaking, the most important thing that we are seeking for the part of the unicorns in our data, and this is something which we can, I would say that it's like to finding mobile phones in old pictures in 1938 or 1928. It doesn't mean that it should be real mobile phones, but interesting patterns which can help us in better understanding in customer experience, in fraud detection and other stuff. And what is the major scope in all of those things? First of all, we have technological challenges from one side, and also we have user expectation. We are aware that the market has been changed, and artificial intelligence, data science is maybe not such in good shape that can follow all these things, because you know that customers became much more offers. They are needing to build that the company should be much more faster. For example, let's assume if you would like to have loan approval for some, I would say, things which you would like to buy, you need this loan immediately. You don't want to wait. Maybe somebody else who has much more quicker approval process will be winner and take much more customers. From the other hand, you are struggling with situation, for example, if you are working in finance industry, that you have to collect the history data, then you develop some kind of the model and you trust to those model, but then you have some disruptive events, and those disruptive events can make big difference when you are developing. And this is the way, and one of the recommendations from here, which I will show you, which potentially can help you in that direction to be much more efficient and much more faster in that way. As you can see, if we are talking about mobile, if we are talking about telecommunication and IPTV and other stuff, let's assume when we are talking about the old good-fashioned way how people are consuming these services. You know that they are just gathering together in some places, they are looking on those TV sets, and they wasn't such demanding if we are just taking in consideration current situation and current users. And if you will look on some population pyramid, and if you look on your portfolio, if we are talking about IPTV watchers, you will realize that really those guys which is in this area in population pyramid is not such demanding. They have their needs, but they are much more tolerant. As you are going down, you will see that there is the much more higher segmentation. And now you have situation that even even young person and kids from 14 to 15 years old, from 15 years old to 17 years old has different approach and has different demand in regarding to that. And we have to make some kind of mix of the products, and you can use, I would say, the same model for all the population. IPTV is just one of, I would say, illustrative way how we can illustrate that. For example, if you are making churn model, it's not a good idea to have the churn model for the whole population, because those population doesn't mean to have been segmented only by age, but also they have some specific requirement and other stuffs. And for example, if we are talking about putting all the data into self-calculatory mechanism, at the end you will potentially, you will get some results, but potentially you will fail with final results. And that's the way that when you are just developing different kind of the model, it's not just about the using of some specific model like EEG boosting tree or something like that. First of all, you have to think about the data sampling and how you will provide the input data that at the end doesn't matter which kind of algorithm will provide you appropriate answer for your question. And this is the key point. Machine learning algorithms learns for history. And you know that you have, for example, if you are talking about the churn models, you have to collect maybe 1 year, 2 year history, and then you have reliable data sample. Then you are developing the model. You have a shift in 1 month for each calculation for each month. And then you hope that you are on safe side and that you have answer to all the questions in realization of calculation of the probability for the churn. But the question is it real, I would say, such simple situation? This is the methodology, and somebody would say, okay, but that's it how it is. But from the other hand, as I have been working a lot of time, I would say almost 20 years in finance industry, the major, I would say, major school from my point of view as a data scientist was financial crisis in 2008. I would say that we have almost, I wouldn't say perfect model, but very good model for credit scoring, behavioral scoring, application scoring. And then happened 2008. Everything became completely different. Those model doesn't reflect reality. We were in situation that we have to do everything from the scratch, because you have to provide the loans, but from the other hand, you cannot trust to your models. And you was in very, I would say, bad situation. Then we have been change our approach. We have relied on expert model based on the fuzzy logic, and mostly have been oriented on very small snapshot of the time from the history, and that helped us to improve our portfolio regarding the risk. And from the other hand, if we are talking about statistical significance, that's the reason why we are using, I would say, such long history to have statistical significance. But from the other hand, if we are talking some of the disruptive events can go under the radar. But you have to recognize that. From the other hand, you know that if you have a lot of I would say small events which is statistically insignificant, at the end, when you sum it up, at the end you will have significant sample without common denominator. And that's also one of the great problem. And the differences and these nuances makes differentiation between good and bad model. I don't say that approach when you are using machine learning algorithms, you are collecting history and you are making to do some kind of predictive model is not good. It's good. But from the other hand, if you would like to be much more precise, you have also to have backup variant and you have to do some kind of additional things. And mostly this is usage of disruptive events, but you have to recognize which one of them they are and how do they react and how they contribute to prediction or segmentation and other stuffs. And from my point of view, from my experience, I will just share with you some of case studies on which I have been worked. For example, this is, I will just say some kind of review of what I already have been talked. Most of the, I wouldn't say most, but mainly if you have unexperienced data scientists, they say, okay, I will get all the data which I have in input, I will put into some black box like XG boosted trees, Bayesian network, whatever, and I will get something. This something can be, I would say, false reliable. For example, you will get a very high ROC curve because of oversampling, overfitting, and other stuffs. And at the end, when you have to invest some money regarding the results from these models, you will be really disappointed. And also, if you care only about, for example, probabilities, if we are talking about predictive models, potentially are in the deep trouble, because if you don't understand what really happened, because probability and calculation of the probability in the model is not just calculation of the probability, because they are constructed with some reason why they are. You have to do some kind of profiling, why it happened. You exactly have to know what contain those predictive function, and then you have materials for decision making, because your decision making is in line with your models. And when you know that there is the high probability for the churn, you exactly know why, and that's the most important thing. Otherwise, if you have only probabilities, you simply don't know, okay, what I have to do with those guys which has high probability for the churn. Maybe I can offer them something, but maybe you will miss the chance to keep them alive because they don't care about that. You have to recognize them that from their profiles. And that's something which I realize that it's very important. And the most important thing in data science, from my experience, is trying to look on the data and problem in different way. Just not to have, okay, I have model, I have algorithm, I have data, I will get results, and that's it. You have to be creative. First of all, I would say one of case study on which I have been working in finance industry was fraud detection models, and not only in finance industry, also in telecommunication. Only what you have is mostly the data. You have something like that, and you even don't have target attribute, and you have to do something. And for example, I will just give you one of the example, transactional credit card fraud. You have data and you have to recognize who is fraudulent cases. And you only have to use common sense. First of all, what somebody who stole your credit card, what he will do. He will behave in different way like you are doing ordinary. If you are spending, I don't know, 200 euros per week or 100 euros per week, you will have several small transactions. If somebody stole your credit card, he knows that he doesn't have much time. He has to act immediately, and as much as possible money he has to create to take out from your credit card. That means that we are talking about extremes. What you have to do to calculate extremes with simple z values. After you do that, in situation, if you have marks for, I would say, z values, you are on good way that you will recognize transactional credit fraud. The fact is that you have to do that on individual level. One person can have, I would say, transaction on 100 euro per week. Another one will have 2,000 euro, and so on and so on. That's the reason why you have to do that on individual level and to trace with those systems this kind of business. And I just would like to emphasize that sometimes you don't have to use, I would say, space shuttle data science method to get out some useful results and to have something which is pretty useful and which you can use for prediction, for realization of your projects and other stuff. As I already mentioned, the keyword in here is extreme, because somebody who stole your credit card behaved differently than you. He is behave extremely, and statistics with z values on individual level can recognize that with sigma values, and very simple, good old Gauss can give you the answer for this kind of situation. Also, using data science methods differently, what does it mean? Previously, I would say it's very recent data, I would say case study on which I have been working with my colleagues. We have been developed recommendation system. And the first reflex when you are doing that, okay, what I will do, I will use traditional methods, CN2, associative algorithms, but where is the catch? Those algorithms are not appropriate for big data environment. The problem is that even in small data environment, you have significant problem with usage of those data. You have to something to catch combinatory explosion. You have situation that you have candidate generation with combinatory, and this is disaster for big data environment. What you have to do? You have to as I said, to use different kind of method with some innovation in that direction. What we have done, we have adapted frequent pattern tree. Frequent pattern tree has been developed by one professor in Canada 10 years ago. He has problem in astronomy, and he for sure in those kind of data environment, he cannot apply for traditional algorithms. And from my point of view, this is the most beautiful, I would say, and elegant algorithm which I ever seen in data science. Only with 2 runs, those algorithms can build a tree of recommendation. Okay, you have to adopt that for your purposes, in this case, for IPTV situation. But at the end, the results of this activity was that less than a second in terabytes of data, you can generate this recommendation tree. That means that you have patterns, you can do some kind of evaluation regarding deep dive, regarding preferences and other stuff with very simple approach. What you have to do, you have to do some kind of little bit programming in PySpark, for example, or something like that. It's not something which you can find out as final product, but with open source and PySpark and whatever, you can do this solution, and at the end, you can avoid 50 factorial of combination, which is pretty huge. But at the end, you achieve your aim. From the other hand, what is another challenge in artificial intelligence? Understanding customer needs on abstract level. We can talk about generally, from my experience, about the world of shells. You are asking, when we are talking about, I don't know, customers, we are talking about, I don't know, years in some buckets, we are talking about earning in some buckets, we are talking about number of calls in some buckets, but the major question is, can we translate whole the word in buckets? You know that when you are choosing book, you are not choosing book by some bucket, you just have some kind of, I would say, preferences for some genre or something like that, but it's not something which you can express by attributes in buckets. You have to recognize some nuance in that direction. And the question is how to seek for abstraction in this condition. For example, let's assume if you have some kind of database the database which contains some kind of multimedia content, and then let's assume that we have some pictures like seashores. If we are talking about the world of shells, you can see seashore. In here we have some common denominators and some little differentiation. But you as a human person, you can see completely, I would say, you have some impression of all of those pictures. You will see, okay, I would like to spend my holiday in this place, but you cannot express that with the shells. And how you can do, and to do some kind of, I would say, analytical method to do that even better. For example, one of the use cases which I have been working, and it's also has been, it's visible in one of my book, it's regarding choosing of the destination for one tour operator. And what we did, we just use and train the algorithms in a way that we are just, I would say, also take from the history snapshot preferences of the choosing regarding recommendation. If somebody are just going to this area and this area, which is the probability that he will end up in some specific part of the world or some specific environment or something like that. And we achieve that we really can, at the end, have very good probability for recommendation in that condition, because they don't put some text or some menu in which they are clicking some options like shells. They are just clicking the pictures, and then at the end they go into final direction. And what was also, I would say, upgrade of this methodology, introduction of fuzzy logic into all this system, in which give us opportunity that you also can, I would say, book of shells with some kind of abstraction put together, and then you can have some kind of situation that, for example, you can make definition colorless, non-colorless with much more blue colors or whatever, that you can predict in situation when somebody is starting for choosing of some particular item for buying, that at the end they will end up with some specific item which they prefer with some specific color. And how you can also do that. With the fuzzy logic, as you can see, you can have some kind of the branches which is related to the hard measures, like similarity by AGB, similarity by items, and also soft measures like colorful playfulness, colorful bluish tones, and something like that. And this is also the approach when we are trying to understand customers in a way not only regarding customer experience about how do they like some company or not, but what they really needs and what is the segmentation behind that to be much more accurate in a realization of the project. And also, from my perspective, something which is very important, especially when you are doing churn models, when you are doing NPS models, customer experience models, to analyze the text, to analyze the comments from which customers gave you. If you have some kind of the service and they put some kind of the comments, and you have 10,000 or 20,000 of comments per week or day or I don't know month, you will be surprised how many of information you can collect from analyzing of the data. But what is also a major problem? The major problem, for example, Croatian languages like some other small languages, potentially very exotic one. For the English, you have a lot of libraries, you have a lot of tools also for the German and big languages, French, and so on and so on. And you can use natural language processing in way as you should do that. For the, I would say, small languages like Croatian language, there is the recommendation from some vendor, if you are using some kind of solution, okay, please translate in English, and then from the English you can do, I would say, some kind of analytics. But you lose a lot of essence when you are doing that. Luckily, we have some kind of solution from Croatian language and small languages in some universities like Institute Josef Stefan in Slovenia, because they have been developed some kind of library for the small languages in this part of Europe. And usage of the native language is something which can give you much more better insight. And what is the most important in that direction? For example, social network analysis, which you are plugging into text mining analytics, because natural language processing, clustering of and topic recognition, for example, LSC method or something like that, can give you the results. But if you just go beyond the limits in a way that you are using social network analysis and clustering of the networks, from my point in my experience, especially in Croatian language, we got much more, I would say, much more better results with much more better information. And if you put together those concepts like traditional machine learning approach with predictive modeling, and from the other hand, you are using natural language processing, you have pretty good, I would say, opportunity to really understand your customers, to understand your users, to have answers for the different kind of situation, like churn, like customer experience, recommendation, and other stuff. Because in that way, you can recognize these disruptive events which make the changes in your portfolio. And when you realize that, then you can make some kind of KPIs into your models, and also to plug in this information from the databases, and then you are in a good way that you will get much better and much more accurate model. Most of those things has been explained in my books, which I have been wrote in previous period, and some of these use cases which I'm talking here about is described in these books. And also there is the, I would say, paradox, which I will always mention in this kind of situation. I talk about the data science, because you know that the market has been changing continuously. But from the other hand, the question is how fast data science has been changed. I know that there is a lot of opportunities on market. You have a lot of initiatives, you have a lot of projects. But from the other hand, in corporative environment, you know that the things is not such easy for making changes. You have to collect the data. You have to set up all the data infrastructure to be ready for this kind of activities. And in case if you are just saying, okay, I will just use the part of the data, because the good is not good enough. Because if you have just the part of the data and you are based your modeling on this, I would say, island of the data, it's not guaranteed that at the end you will have something which will really helps you in the realization of your project, and to be much more, if we are talking about a decision support system, something which can be useful for realization of your projects. Thank you for your attention.
Gosh, Goran, what a lot of information. I heard what you said about that combination at the end is what's going to deliver the value. I'm just wondering, do you think we are looking at incremental improvements with artificial intelligence, or do you think there's something on the horizon that's going to be a really big jump forward?
Yes, I have been in situation, you have data scientists from my experience, which I have been worked together. They are specialized for example, for the content mining in multimedia area. You have specialists in text mining. You have specialists in predictive analytics. But just imagine a situation when you put all these things together. You put churn models together with recommendation model from the web when you recognize this kind of analysis. And this is something which I see as future challenges. I know you don't have, I would say, appropriate tools that some vendor will just provide you. I don't say I like vendors, just to be just for me that somebody will not have a wrong impression that I'm just, I would say, using open source only. I'm also using very great tools for data science and from the vendors. But I just would like to say that even if you're using great tool, you cannot expect that after you will collect the data and put those data into some calculatory mechanism that at the end you will get the magic. You will not get, you will lose your point, the major idea is that you understand, first of all, that you have the aim, what you have to achieve. And then from this one, you are just going down and collect all possible information which you have together and different kind of methods to realization of this aim.